Okay, so I think today I want to just quickly run down what the next couple weeks are going to look like. So the plan for today, actually we're going to kick 8.4 to the, oops, to the next class. There we go. Um, so the plan for today is to continue on with chapter 8, solving equations. Um, and I think I think we've mostly finished that up as well. But anyway, we're continuing on with chapter 8, solving equations. And the goal for today is to get up to where we're solving equations with variables and constants on both sides. So where we might have some two-step equations and even more than that. So that is our goal for today, to get up to where we're solving, in essence, the most general linear equation out there. So then we'll be able to solve any linear equations. Um, on Thursday, we will finish up this discussion on chapter 8 and do a quick review of chapter 8. Next week, we have Thanksgiving break, so no class meetings. And then when we come back, it's kind of a flurry of activities. So when we come back in December, we have basically 1 week. We have the Tuesday and Thursday class meeting where we'll be talking about some selections in chapter 9. So 9.1 through 9.3, and then some selections from 9.4 through 9.7, depending on how much time we have left to the end of Thursday's class. And that's actually our last class meeting. So we have today's meeting Thursday, Thanksgiving break, and then 2 more class meetings when we come back, and then we're into finals week. Note that the Unit 3 exam is scheduled, so that's sections 5.6 and 5.7, as well as chapters 6 through 8. That's scheduled for the week of December 2nd through the 8th. So that's the week that we come back from Thanksgiving break. And final exam week is kind of technically Tuesday, what is that, 12/8, Tuesday, December 8th or 9th or something like that, um, through that coming Friday, or that Friday the 13th. But just because I know that weekends tend to work better for some folks, especially folks in remote courses, I'm opening up the final exam on Friday, December 6th, so a little bit before final exam week. And it will remain open through midnight on Friday, December 13th. It's a comprehensive exam, chapters 1 through 9. And, the same statements as before go with Unit 3 exam, and especially the final exam. Do not wait until the last minute to take the exam. Plan to take it at least a couple of days before the due date. Note that the final exam is due, I'll put this in bold, on Friday, December 13th. So a lot of our due dates have been Sunday, but because of the end of the semester, I need some turnaround time to get things submitted and all of that. And the course ends technically on that Saturday, I think, but we're making the due date Friday at midnight, so that I have time to get everything graded, get all the grades compiled, get final course grades uploaded in a timely fashion. So the next couple weeks we have a lot going on, but I think it's manageable if we take it in small chunks. The 2 quotes of the day today touch on points that we've talked about before. We've seen this quote before from my favorite professor, Dr. Layton. Good decisions come with experience. Experience comes from making bad decisions. So I think this is a good time of the semester. Each semester as you're kind of heading into final exams, final papers, projects, labs, all of that kind of stuff, to look back and say, okay, is there anything this semester that didn't go so great that I wish I had made a decision differently? And looking forward to this really crunch time period of the semester, can I take that lesson? Can I take what I learned from there and, apply it moving forward and make this challenging time of the semester maybe go a little more smoothly, be a little less stressful? And, just another note on margin, you must create margin so that you have room for what's important, not merely urgent. So I know that it's super tempting to take Thanksgiving break completely off and do nothing during Thanksgiving break, especially for a 2-day week class. That's almost like a week and a half break. So there's, a week and a half where you're kind of not doing, say, for instance, any math at all or anything for a lot of your classes. And then you come back and you have 1 week to basically pick up all that momentum again before finals week. Thanksgiving is very late this year. It's as late as it can possibly be. So we only have this 1 week before the finals when we come back. I would strongly recommend touching base with the material at least a couple of times over Thanksgiving break. Maybe that looks something like on Tuesday, knocking out a homework assignment or two, maybe doing a little bit of review of, a past topic or two that you maybe struggled on. Maybe say the Saturday after Thanksgiving, again, maybe doing another homework set or something like that. Maybe putting together a, study guide or a study plan for the Unit 3 exam, studying for that exam, looking forward to the final and, putting together a study plan for that. So that way you're touching base with the material a couple of times. You can still take a break. It doesn't have to be as strenuous as a normal class week, but, I think doing that in this course and your other courses as well, putting in a little bit of time, at a couple of points during the break, will make those next couple of weeks go so much more smoothly and so much better. And then once you hit, Friday the 13th or whenever all of your final exams and papers and projects and all of that are done, then, then kick your feet up, go party with your friends, whatever you want to do at that point. You have a month off until spring semester starts. So, enjoy that time. But, take Thanksgiving break as maybe a little bit more like a working vacation kind of philosophy, so that when you come back, you're really ready to go into these last couple of weeks. Any questions on anything before we get started? Okay. And I will try to, um, keep this at the beginning of each.
So do we have a quiz before? Do we have a test before the final?
Yes, Unit 3 exam, the week when we come back from
I didn't
Thanksgiving.
even, okay. I didn't
Yep.
see it until you highlighted just now. Okay, thank you.
Yep. Yeah, sure. Yeah, that's the week we come back from Thanksgiving. So that's also the week before final exam week. So there are 2 weeks in a row that we have an exam. And the dates even actually overlap a little bit. Um, and that is just because Thanksgiving break is so late. Usually we come back from Thanksgiving break and we have 2 weeks and then final exam week. But with Thanksgiving being so late this year, we just have the 1 week and then final exam week. So it is, it was a little more of a slog on the front end. We had an extra week before we get a break, and it's a little more hectic on the back end whenever Thanksgiving break ends up this late. But yeah. Okay. Um, Yeah, and I will try to, post this each class meeting so that we kind of just have a view of what's ahead of us. Also, I have the I think I posted all of the chapter 8 homework, and then depending on what we get through this week, I'll make plans for Tuesday and Thursday for chapter 9 and post that homework so that you'll have more of a view of all of the homework that's going to be due for the next well, for the rest of the course, so you can make plans for for that time as well. Okay, so finishing up 8.1, solving equations using the subtraction and addition properties. Yeah, we have uh, a couple more problems here. So we have a word problem. Suppose we want to drill a pilot hole for a 7/16 inch diameter lag bolt. The bolt should be 1/8 inch larger than the hole to allow the threads to grip properly. So we want the bolt to be larger than the hole. If the bolt was smaller than the hole, it would just fall out. Let D be the diameter of the hole needed. And we want to solve the following for D. So the diameter of the hole plus 1/8 inch has to equal the 7/16 inch diameter of the bolt. So we have variable plus number equals number. Our numbers are fractions, but we can still solve this equation using our same equation solving property. We have variable plus number equals number. we isolate our variable term by subtracting that 1/8 off of both sides. D plus 1/8 minus 1/8 is just D. And on the right-hand side, we have 7/16 minus 1/8. Or I see that this is 7/16 minus 2/16. Multiplying 1/8 on the top and bottom by 2 gives me a common denominator, or 5/16. So the desired hole diameter needed is 5/16 of an inch. Okay, let's look at this next example. Translate to an equation and then solve. 12 less than x is equal to 17. Let's be a little bit careful. If I have like, $5 less than I had yesterday, I had like yesterday's amount minus $5. We might be tempted to write 12 less than x is something like 12 minus x, but it's actually the other way around, right? So 12 less than x is x amount minus 12 is equal to 17. And again, we see that we have an equation where I have variable plus or minus number equals number. And I know that I can add or subtract this number. In this case, I will add 12 to counteract the minus 12. And I'll do that to both sides. And I see I get x equals 17 plus 12, or 29. Okay, to wrap up section 8.1, take maybe 30 seconds or so, take a look back at the couple of problems we did here, as well as the last class meeting notes, and try to find a general method to solve x plus a equals b, where here x is a variable and a and b are constant real numbers. So take maybe 30 seconds or so, write down the solution, x equals what, in terms of a and b. Okay, so for x plus a equals b, again, we have this general form of x plus number equals number. Let me subtract a from both sides to get x by itself, so I isolate the variable. And I get x equals b minus a. Right, so that's the more general solution. If I have x plus a equals b, I can associate which number is a, which number is b, and then just take their difference, b minus a. Okay, so moving on to section 8.2, solving equations using the multiplication and division properties. So here I have number times variable equals number, instead of something like variable plus or minus number equals other number. Number times variable equals number. The number that multiplies the variable is often called the coefficient of that variable. So here 3r, 3 would be the coefficient of r. And if I want to kind of undo this multiplication by 3 in some sense to get the r by itself, I would multiply by the multiplicative inverse. So we talked a little bit more about some of this terminology last time, but I want to multiply by the multiplicative inverse. I want to multiply by 1/3 on the left-hand side. So the 3 times 1/3 gives me 1, or just a factor that I don't have to write. If I multiply by 1/3 on the left, if I divide the left by 3, I want to multiply by 1/3 on the right. So 3r times 1/3 is just r. And on the right, I have 9/2 times 1/3. Well, 9/2 times 1/3 is 9 times 1 over 2 times 3. And I see that the factor of 3 in the denominator divides out one of the factors of 3 in the 9, leaving me with just the remaining factor of 3. So I can say r equals 3/2. Now, when I solve an equation, ideally, I also want to, as a last step in the process, check, is it true that 3 times 3/2, is that equal to 9/2? And yes, 3 times 3 is 9 divided by 2. That is correct. So ideally, I want to check after every time I get a solution. For time considerations, I often won't check our solutions fully at the end, but ideally we would check each of these. Okay, so take about maybe 60 seconds or so, maybe a minute, 90 seconds, something like that. And try to solve this one. 5r equals 15/7. In a minute or so, we'll come back and discuss the solution. Okay, it's been just about a minute. So we have number times r equals number. 5 times r equals 15/7. And again, I can think of multiplying by the multiplicative inverse of the coefficient, 1/5, and doing that on both sides. 5 times r times 1/5, well, that just gives me 5 times 1/5 r, or just 1 times r. And 1 times r is just r. And on the right side, I have 15/7 times 1/5. And I see that the factor of 5 in the denominator divides out with the factor of 5 in the numerator, leaving me with r equals 3/7. Now, what if I have something like this one? 7m plus 3m equals 5. Before I do any equation solving steps, and after each equation solving step, I want to fully simplify everything. I want to take each expression on each side of my equal sign and simplify it as much as possible. So that might mean expanding it out. That might mean combining like terms, things like that. And here I notice on the left side, 7m plus 3m, those are like terms. I can combine them together to make 10m. And on the right side, I just have the number 5. That's just what it is. Now I could think of multiplying each side by the multiplicative inverse of 10. I could think of dividing by 10, but I could also think of multiplying by the multiplicative inverse of the coefficient to get the variable by itself, multiplying both sides by 1/10. 10m times 1/10 gives me just m on the left. And on the right, I have 5 times 1/10. Well, that's like 5 over 1 times 1 over 10, or that's 5/10. Or we can see that's 1/2. Okay, so take about maybe 30 seconds or so and solve this one. 8m minus 2m equals 4. Okay, so similar structure to the one we just did. 8m minus 2m, those are like terms. I have 6m on the left side and equals 4. Nothing I can really do to that right-hand side. I have number times variable equals number. I multiply by the multiplicative inverse of the coefficient 1/6 and multiply that by that on both sides. 6 times m times 1/6, that's 6 times 1/6, or 1 times m, just m. And 4 times 1/6 is 4/6, or m equals 2/3 once we divide out the factor of 2. Any questions so far? Okay, what about a problem like this? If I look at this, this looks like a really complicated problem, right? It looks very challenging. There's a lot of parentheses. There's a bunch of different terms on both sides. But this actually simplifies down quite a lot. So before I go trying to solve the equation, trying to apply equation solving steps, again, I want to kind of think of splitting this equation in half, look at the left expression by itself, look at the right expression by itself, and simplify as much as possible. So let me start with 5 times x minus 1 minus 2x plus 5. We'll just look at the left-hand side for now. Can I see anything I can do here to simplify? Well, I know I have the distributive property that I can apply, multiplying this 5 through the binomial, giving me 5x minus 5 minus 2x plus 5. I have a commutative property that I can apply if I'm careful. I can think of this minus 2x like a plus a negative 2x, and this minus 5 is like a plus negative 5. And I noticed that minus 5 plus 5 just nets out to 0. 5x minus 2x is just 3x. So let me actually write that up here, save a little bit of space. So my whole left-hand side that looks pretty complicated, that really just boils down to 3x, that's all. And what about my right-hand side? It also looks quite complicated, but again, I think I might be able to simplify this a little bit. So I have 4 times x minus a half minus 4 times x plus a quarter. And here I want to think of this minus 4 times stuff. Let me move this over a little bit, get a little extra room. I want to think of it as a plus negative 4 times that stuff. That's going to help me when I apply the distributive property. It's going to help me to remember to distribute that negative appropriately. And I can apply the distributive property to the first term as well. So I get 4x minus 4 times 1/2. That's minus 2. plus a negative 4x. And then plus negative 4 times 1/4 is plus a negative 1 or minus 1. I can use my commutative property again if I'm careful to think of minus 2 as plus a negative 2. And my 4x and my minus 4x are added together. They are opposites. Their sum is 0. So this whole right-hand side just turns into negative 3. In other words, my whole equation up here simplifies down to 3x equals negative 3. Right? It was well worth doing that simplification first, getting the left-hand side as simple as I can, getting the right-hand side as simple as I can. And now the path is pretty clear. I have just one equation solving step I need to perform. I have number times x equals number, multiplied by the multiplicative inverse on both sides, multiplicative inverse of the coefficient of the on the x. 3 times 1/3 is 1. 1x is just x. And negative 3 times 1/3, negative 3/3 is negative 1. And again, we could come up here and plug in x equals negative 1, check our work, make sure we get the same number on both sides of the equation. But just for time considerations, I'm not going to do that on every problem. Okay, so take a look at these two exercises. The first one solving this equation. Again, this is a complicated looking equation, but just like the one above, I think if you simplify the left-hand by itself, the left-hand side by itself, then simplify the right-hand side by itself, and then put the simpler forms back together, the path forward will be a lot more clear. And then also as an exercise, find a general method to solve a times x equals b, where x is a variable, a is not equal to 0, and b, a and b are constant real numbers. So maybe take about, let's say maybe 4 minutes to solve these two. It's going to take a little while to do all the simplification, be really careful with all the minus signs and all of that. So we'll come back in about 4 minutes and discuss these two exercises. And maybe about halfway through, I'll give you a bit of a hint on this first one. Okay, everybody. So it's just about 4 minutes. If you didn't, finish everything, that's perfectly okay. But hopefully you got a pretty good start on at least the first exercise. So simplifying down, we end up with the left-hand side actually simplifies all the way down to just 9x. The constant terms cancel out, and we can combine the variable terms together to get 9x. And the right-hand side, the variable terms cancel out, the constant terms combine to get -12. So this whole big initial equation up here simplifies all the way down to 9x equals -12. We have variable or coefficient times variable equals number. We multiply by the multiplicative inverse of the coefficient. To get the variable by itself, we multiply by 1/9 on both sides. And we get x equals -12 times 1/9. Well, that's really like -12 over 1 times 1/9. I can divide a factor of 3 out of the top and bottom and get -4 divided by 3 left over. Any questions on that one? One of the main points here, in addition to the overall strategy, is being really careful when distributing this -4. It's really easy to forget and make this like a -4x plus 8. It's really easy to get that sign wrong. And then this would end up looking like a, what, +4. So if you ended up with 9x equals +4, you might have made that mistake, not quite distributing that negative along with that 4 and the -4x plus 2. And our general method to solve ax equals b, where a is non-zero, is to divide both sides by a, or multiply by 1 over a. So our general form of the solution is x equals b divided by a. Any questions on any of these, what we might call like one-step equations, where we had to apply one equation solving step to get the solution? Okay.
Oh, you got the 4. Right there, what did you take away to get the 4?
Yeah, so we have x is -12 times 1/9. And this would be, say, -12 over 1 times 1/9. So this is -12 over 9. And I could write 12 as 4 times 3 and 9 as 3 times 3, and then divide out the 3's. Any other questions?
No, thank you.
Yeah, sure. Okay, so now we're looking at solving equations with variables and constants on both sides. So we saw that if we look back at these patterns, we have kind of a variable that's by itself plus a constant equals a constant. So it took one equation solving step to get the answer. Just subtract 1/8 from both sides. There was only one thing we need to do to both sides simultaneously to get our answer. We had some simplification to do, right? But the simplification doesn't count as an equation solving step. It's just something we do between every step. Same thing here. I had to do one equation solving step, add 12 to both sides. Or here I had to do one equation solving step, multiply by 1/3 or divide by 3. You can think of it either way. Same here, one equation solving step, one equation solving step, one here as well. Here I had to do a bunch of simplification, but really just one equation solving step. Same here, bunch of simplification, but it simplified down to just where all I had to do was one equation solving step, one thing that I did to both sides simultaneously. Now, something like this, in section 8.3, I have a situation where I need to do two equation solving steps. I always want to simplify first. In this case, I don't have anything I can really simplify, but sometimes I will. I simplify first, then I do an equation solving step, then I simplify as much as I can. Then I do, if I need to, another equation solving step and simplify as much as I can. And I keep repeating that process until I get the solution. Now, for something like this, I have 3a minus 1 equals 11. My variable term has a constant term added onto it, and my variable itself has a constant multiplied against it. I don't want to start by, say, dividing by 3 or multiplying by 1/3 on both sides, because if I do that, I mean, in theory, I can do this, but in practice, it's really annoying to do. Because if I multiply by 1/3 on the left, then I have to do some kind of distributive property, and I have a bunch of fractions floating around. I want to deal with fractions as little as I reasonably can. They're just more difficult to deal with in general than, whole numbers or integers. So I see that I don't want to start with the multiplying by the multiplicative inverse equation solving step. What I would like to do is think of this variable term 3a, and I want to get it by itself. I want to get 3a equals number. How do I do that? I apply an equation solving step, say adding 1 to both sides. I have 3a minus 1. If I add the additive inverse to both sides, if I have minus 1, then I add plus 1 to both sides. Minus 1 plus 1 equals 0. So I have 3a on the left-hand side equals, and 11 plus 1 is 12. I applied one equation solving step. I use my addition and subtraction property of equations, applied that equation solving step. Now I get 3 equals 12. Is there anything I can simplify? Well, no, this is pretty simple, right? The left-hand side, that expression 3a, nothing I can simplify there. Same with the right-hand side expression 12. Okay, now I'll do a second equation solving step. I have number times variable equals number. My coefficient of my variable is 3. I multiply both sides by the multiplicative inverse of the coefficient, 1/3. So I've isolated my variable term. I'm now working to isolate the variable itself. 3a times 1/3 gives me a. And on the right-hand side, I have 12 times 1/3. I've done that equation solving step. Is there anything I can simplify? Sure, 12 times 1/3 is 12/3 or 4. Do I need to do anything further? No, this is the solution. A equals 4. And then lastly, I probably ought to check, is it true that 3 times 4 minus 1, is that equal to 11? Is it true that 12 minus 1 equals 11? Yes, that's true. So I know that a equals 4 is the one and only solution to my original equation. So note that I applied 2 equation solving steps here. And my goal was to first isolate the variable term. So get the 3a by itself. And then my next goal was to isolate the variable itself, getting the a by itself. Because of course we're looking for a equals number, that's the form that our solution will take. So we isolate the variable term first, and then isolate the variable itself. Before the first equation solving step, and in between any other equation solving step, and I suppose after the last one, we always simplify, right? We want our complexity to go like this over time, not to go like this and then try to find our way back down this very steep hillside over here. We don't want to make things really complicated and then have to do a whole bunch of operations in one step. That's no fun. maybe arguably doing this isn't fun anyway, but it is useful. Um, but we want to simplify at each step as much as we can. We didn't really have to do much simplification here. Um, we just did the 11 plus 1 equals 12. I mean, I suppose that might count as a simplification. We didn't have to do a whole lot here until the end. But in other problems, we like these ones, we might have a lot of simplification to do that make our lives a lot easier. Okay, another little practice here. Solve 5x plus 7 equals 4. Again, I have the same kind of format, same kind of structure as up here. I see that maybe I could try to get the variable by itself by, say, dividing both sides by 5 or multiplying by the multiplicative inverse of the coefficient, 1/5. But if I do that again, I have to distribute to this left-hand side. I am going to end up with a 7/5. I'm now moving around fractions to isolate the variable. Don't really want to do that. So I'll consider the 5x term, and I'll start by isolating the variable term. There's nothing, I should explicitly state, there's nothing I can simplify here. The left-hand side, 5x plus 7, simple as it can be, and same for the right-hand side, just the number 4. I can't simplify anything. So I'll start by isolating the variable term, trying to get the 5x by itself. 5x plus 7, I add the additive inverse, -7, to both sides. 5x plus 7 minus 7 is 5x. 4 minus 7 on the right-hand side. Well, 4 minus 7 is like minus 7 minus 4. That's -3. So I applied one equation solving step, subtract 7 from both sides. And that isolated my variable term, the 5x. I have 5x equals number now, 5x equals -3. Now I want to isolate the variable itself. I have coefficient times x, 5 times x. I multiply by the multiplicative inverse of the coefficient. I choose the multiplicative inverse because it's multiplied onto the x. So 5 times x times 1/5, the 5 times 1/5 will make a 1, leaving me with just 1 times x, or we just write that as x. That's on the left-hand side. And on the right-hand side, I have -3 times 1/5. Not a whole lot of simplification I can do here, but I can write this as a single fraction. Can say x equals -3/5. Any questions so far? Okay, what about something like this? Solve 3a minus 1 equals 4a. This has a similar structure to this one up here, right? Except that on the right-hand side, there's a bit with a variable in it, this 4a. I want to kind of do the same thing. I want to work on isolating my variable term first. In other words, I want to get all my variables on one side by themselves. So I guess I could subtract 4a from both sides, but then that would put the a's kind of on the same side as the numbers, and I have to do even more work to get the a's by themselves. I could go the other direction, though, and kind of pop this 3a onto the right-hand side where there are already only a's. That might be a little easier, right? There's usually a couple different ways you can approach any of these problems. And it's not that one way is right and one way is wrong. It's often just the case that one way the calculations are a little easier or a little less error prone. Easier calculations tend to be less error prone. You're less likely to make silly mistakes like forget to carry a negative sign along with it or something. So, you know, fewer steps also means less opportunity for error. So it's not just the time savings, but also the savings of the likelihood of making a mistake goes down. So I'll choose to put my 3a on the right-hand side. It'll combine with that 4a, and that will isolate my variable term. I'll end up with something like number times a equals number. To get my 3a onto the right-hand side, I add its additive inverse, negative 3a. On the left-hand side, 3a minus 3a is 0, and I just end up with negative 1. On the right-hand side, I have 4a minus 3a. Well, hey, that's just a. By isolating the variable term, it was kind of nice. I ended up actually isolating the variable itself. I have a equals negative 1 is my solution. I got lucky here and didn't have to do a second equation solving step. Now, if this had been 2a minus 1 equals 4a, 4a minus 2a would be 2a, and then I have to do another equation solving step to get that coefficient of 2 off of the a to isolate the variable itself. But here, I did one equation solving step and I kind of got lucky, got my solution right away. Okay, so take a look at these three exercises. So solve 4a minus 7 equals 9, 14x plus 1 equals 8, and 7a minus 1 equals 8a. And take maybe, let's say about 5 minutes and work through these three problems. And maybe a minute or two in, I'll kind of write the first step up on each of them. And then after about 5 minutes, we'll come back and we'll finish them up. Okay, so take about 5 minutes on these three problems. And just FYI, if you do have any questions or any thoughts or anything like that, feel free to pop any of that into chat. You know, I'm monitoring chat and all that. So if you have questions or you're stuck on something, just pop it in the chat. Okay, so I wrote up the solutions as we were working through them. So for this first one, 4a minus 7 equals 9. The first thing we want to do is isolate the variable term, get that 4a by itself. We see that 4a has a minus 7 attached to it. We choose to add the additive inverse of minus 7 or plus 7 to both sides. So I have 4a minus 7 plus 7, just 4a on the left side, equals 9 plus 7 or 16. Now I have 4a equals 16. I want to isolate the variable itself now. I want to get the a by itself. It is multiplied by 4. I choose to multiply by the multiplicative inverse of that coefficient, 1/4, on both sides. So I have 4 times 1/4 is 1 times a, or 1a we just write as a. And on the right side, I have 16 times 1/4. 16/4 is 4. So I have a equals 4. And then I would plug back in and check, is it true that 4 times 4 minus 7 is 9? Yeah, that's 16 minus 7. That does equal 9. That does satisfy the original equation. Second problem, solve 14x plus 1 equals 8. Again, I see I want to isolate the variable term first that has a plus 1 added to the 14x, the variable term. Well, I add the additive inverse, minus 1, to both sides. So 14x plus 1 minus 1 gives me just 14x on the left-hand side. And on the right-hand side, 8 minus 1 is 7. So I now have the simpler equation, 14x equals 7. And now I want to isolate the variable itself. The x has a 14 multiplied against it. I want to multiply by the multiplicative inverse of that coefficient 14. I multiply by 1 over 14 on both sides. 14 times x times 1/14 is 1 times x, or just x. And the right-hand side, 7 times 1/14, well, that's 7 over 14. I can divide out the factor of 7 on the top and the bottom, giving me x equals 1/2. So I've now isolated the variable, x equals 1/2 is my solution. And on the third and final exercise, well, 7a minus 1 equals 8a. I have my variable terms in two different places. My first step should be to, again, isolate the variable term, try to get the variable terms all together. And I suppose I could do that by putting the 8a on the left side to get 7a minus 8a. But then I have to do something with the minus 1 because that's still attached. So I would have to do two steps then. I could do things a little more quickly and efficiently by putting the 7a on the right side to kind of combine with that 8a that's already over there, kind of by itself. So I choose to add the additive inverse of 7a to both sides. I choose to add negative 7a to both sides. 7a minus 7a on the left side, those go away and just leave me with negative 1 on the left. On the right side, 8a minus 7a leaves me with 1a. That isolated the variable term. And kind of, luckily, that also happened to isolate the variable itself. So I get my solution just kind of falls right out, a equals negative 1. Any questions on any of these three? Okay. So we have an example like this one. This is pretty similar to the one we just did, but just to kind of recap, we want to isolate the variable term. We do that by, say, subtracting 5x from both sides, and I get 7 equals x, and that's my solution. Now, more generally, what if we didn't get so fortunate? What if I had, say, something like 3a minus 1 equals 10a? I noticed that this has the same kind of structure, where I have my variable split between both sides of the equation. I still want to get my variable terms together to isolate the variable term. And it probably still makes sense to put the variables on the right side, since there are no constant terms on the right side, there's just the 10a over there. So if I put the 3a onto the right side, I've kind of already isolated the variable term. There's nothing in theory wrong with going the other direction and moving the 10a onto the left side, but then I need to do more work to get rid of the constant term over there and move it to the other side. So I might as well take advantage of the situation I have here and move the 3a to the right side. To get rid of the 3a on the left side, I'm going to add its additive inverse, or subtract 3a, and I'm going to do that to both sides. 3a minus 3a makes 0, and then minus 1. On the right side, I have 10a minus 3a, or that is 7a. Now I see that I'm not quite as fortunate as I was up here. I have 7a equals -1. I don't quite have a solution yet. I do need to do one more solution step. Isolate the variable itself. I need to get a by itself. I was fortunate up here that it just so happened that my coefficient of the variable turned out to be 1 and I didn't have to do any extra work. But more generally, I'll have to do this extra step. 7a equals -1. I have my 7 multiplied against my variable. I choose to multiply both sides by the multiplicative inverse of that coefficient, 1/7. And I have on the right-hand side, 7 times 1/7 is 1, times a is 1a, or just a. And on the left side, -1 times 1/7 is just -1/7. So I just have a equals -1/7. And actually, we can get rid of this one. So just one exercise. Solve 7a minus 1 equals 15a. Let's take maybe 30 seconds for it. So I think this should go pretty quickly at this point. We've seen a few of these. So about 30 seconds, we'll come back and work through the solution. Okay, it's about 30 seconds. So again, we see that our variable a is split between both sides. So isolating the variable term will mean moving one of our variable terms to the other side so they can combine together. And in this case, again, I think it makes sense to move the 7a to the right because the 15a is already kind of isolated. So if I lump the 7a in with that, my variable term stays isolated. If I move the 15a to the left, then I've still got that constant term -1 that I have to do something with. So I'll choose to move the 7a. I have a positive 7a over here. I add its additive inverse, -7a, to both sides. 7a minus 7a gives me 0, the additive identity, right? And then -1. So the left side just simplifies down to -1. And on the right side, 15a minus 7a, that's going to give me 8a. Now I have 8a equals -1. I want to isolate the variable itself. My variable a has a coefficient of 8 multiplied onto it. I want to get rid of that, so I use the multiplicative inverse, 1/8, which I multiply onto both sides. 8a times 1/8, that's 1a, or just a. And -1 times 1/8 is -1/8. Any questions on that?
Great explanation. I got the answer. Thank you.
Oh, good. Great. Okay, so what about a problem like this? So solve 3a minus 1 equals 10a plus 5. This kind of looks a little bit like this one, where I have my variable term split on both sides. I have a 3a on one side and a 10a on the other side. But it also shares some of the properties of, say, something like this, where my constant term, my plus 1 and my 8, I have constants on both sides as well. My overall strategy stays the same, though. First, I want to isolate the variable term. I want to work towards getting number times a equals number. When we get maybe more used to these, we might be able to do this in one step with several different calculations all at once. But for right now, we're going to break this into two component parts. We're going to break this into, I guess I'll use red. I'm not really warning against anything here, but just looking for a different color. Isolate the variable term. We'll try to get the variable terms together. So get the variable terms together on the same side as one another, combined into a single variable term. So I should only see, after this first kind of sub step, I should only see in my equation the variable coming up one time. Right now I see I have, there's an a and there's another a. It's showing up twice. So first I want to get the variable terms together, and then I want to isolate the variable terms. Or isolate the variable term. At that point, I'll only have one variable term. So like I said, when you get more confident with this, when you get more used to doing it, you can kind of do these two steps in the same line. But for now, we're going to break them into two separate sub-steps. So to get the variable terms together, I can either move the 3a to the right side or move the 10a to the left side. Now, again, in theory, it doesn't matter. Frankly, in practice, it doesn't matter a whole lot. But I like to think ahead as like one step. And I think, well, if I move my 10a to the left side, what's that going to look like? It's going to look like subtracting 10a from both sides. Then I have 3a minus 10a. I have a minus 7a minus 1 equals 5. It's kind of annoying to have a negative coefficient, right? It's easy for me to maybe mistakenly leave off this negative at the very beginning here. Just forget about it when I'm copying things down. When I divide by it, I have to divide by a negative number. Again, that's not, the end of the world. I can do it, but why have a negative coefficient when I can't avoid it? I can always choose to put my variable term on one side with a negative coefficient or the other side with a positive coefficient, right? So if I put everything to the left because I'm subtracting 10a from 3a, that makes a negative coefficient. I'd rather put my a's on the right. I'd rather subtract 3a from both sides. And that's going to give me a 10a minus 3 as a 7a. That has a positive coefficient. So that's just a little nicer to work with. Again, is it the end of the world if you do it the other way? No, it's not. Just be careful with your negative sign. If you had a negative 7a and so on, a lot of times I would even just write a parentheses around that negative 7 just to remind myself that there's like a negative sign there so I don't forget about it. So it's not the end of the world if you do it the other way. But I think it's just a little bit easier to do it this way. I get to choose which side I want to put my variable on, and I'll choose the side that gives me a positive coefficient. because why not? 3a minus 3a, that goes away, and I have minus 1 on the left. On the right, I have 10a minus 3a is 7a plus 5. So I look at this revised equation here, -1 equals 7a plus 5. I've got my variable terms together. I only see the variable coming up one time in this 7a term. And now isolate the variable term. I want to get the 7a term by itself. It has a plus 5 added onto it. I'll choose to add the additive inverse, -5 to both sides. On the right, I have 7a plus 5 minus 5. That's just 7a. On the left, I have -1 minus 5 is -6. And I've now fully isolated the variable term. I have number times a equals number. Everything is as simplified as it can be. 7a equals -6. Nothing really to simplify there. Now I'll go to my next equation solving step to isolate the variable term. Or, sorry, isolate the variable itself. I have 7 times a equals -6. The 7 is multiplied onto the a, so I will multiply by the multiplicative inverse, 1/7, and I'll do that on both sides. 7a times 1/7, that's 7 times 1/7 makes 1, and 1a just makes a. And on the left side, I have -6 times 1/7, or that's just -6/7. So that's my answer. Ideally, I would now plug this back into the original equation, check that I get the same number on both sides. Again, for time considerations, we're not going to worry about that on a lot of these problems, but we would see that this is the one and only answer, one and only solution to this equation. Now note that I had to apply actually 3 equation solving steps here. It took me 2 equation solving steps to isolate the variable term because I had to do one operation on both sides of the equal sign to get the variable terms together, then another operation to get the constant terms together, essentially, to isolate the variable term, and then another one to get the variable by itself. So even in these, slightly simpler problems where we still had to do, isolating the variable term and isolating the variable itself, we were able to get away with just 2 equation solving steps, 1 and 2, when we only either had the variable split up between the 2 sides or the constant split up between the 2 sides, but not both. When we have both the constant and the variable terms split up between 2 sides, we need to do one operation to get the variable terms together, another operation to get the constant terms together on the other side, and then a third operation to get the variable isolated. So these are a little bit longer, but the strategy is still the same. We want to isolate the variable term and isolate the variable itself. We just have kind of one extra little job to do in isolating the variable term, and that is getting the variables together so that we only see one variable anywhere in the equation, and then isolating that term. Okay, let's look at another one of these. So I have 5x plus 7 equals 12x minus 8. You can have an extra space in here. Yep. So again, the first thing I want to do is isolate the variable term. Well, I suppose the very first thing I want to do is check and see if I can simplify anything. I can't simplify anything here. So the next first thing I want to do is isolate the variable term. And again, here I want to first get the variable terms together. then isolate the variable term. So those are my two kind of sub-steps for this step. So I can, well, I could either subtract 12x off of both sides, but that's going to give me 5x minus 12x, a negative coefficient. Why have a negative coefficient when I don't need it? I'll go the other way. I'll subtract 5x off both sides, put my variable term on the right-hand side. 5x minus 5x is 0, plus 7 is 7. 12x minus 5x gives me 7x, and minus 8. I now want to isolate the variable term. I want to get the 7x by itself. It has a minus 8 essentially added onto it. I want to add the additive inverse of negative 8. I want to add positive 8 onto both sides. That gets the minus 8 off of the 7x, because minus 8 plus 8 gives me 0. 7x on the right-hand side, and that equals 15 on the left. I've now successfully got my variable terms together and isolated the variable term. And now I want to isolate the variable itself. I have 7 times x. 7's multiplied against the x. I want to multiply by the multiplicative inverse, 1/7, on both sides. 7 times 1/7 gives me 1. So I just have 1x, or just x, on the right. And 15 times 1/7 gives me 15/7. And we could leave it that way. If we wanted to, I suppose we could also write it as, I know that 15/7 is like 14/7 plus 1/7, or 2 and 1/7. Right? If I wanted to write it as a mixed number, I could do that if I chose to write it in that format for the answer, or maybe a decimal approximation. So 2.14 or so, to the hundredths place. So I could write my answer in a couple different ways, but x equals 15/7 is our answer. And again, we would ideally plug back into the original equation and check our answer. We won't worry about that for time considerations. Okay, so maybe take about 6 minutes or so. These problems are a little more involved. Take about 6 minutes and work through these two problems. And I will put up the general strategy here. So the general strategy for solving linear equations: simplify or combine like terms to get to standard form, where we have ax plus b equals cx plus d. And I suppose don't worry too much about this with a bigger than or equal to c part. Get the variables on one side, the side that makes the coefficient positive, and constants on the other side. So isolate the variable term. Divide to get the solution, isolate the variable, and check. So we have simplify. We have isolate the variable term. And then we have isolate the variable itself. And then, of course, check at the end. Oh, that messed everything up. Let's see. I can do this and that, and I think I can get everything on the screen. Okay. All right, so take about 6 minutes, work through these two problems. If you have a little extra time, check your solution, but we'll touch base in about 6 minutes and go through the answers. Okay, it's just about 6 minutes, so let's take a look at the solutions to these. So for our first one here, 7a minus 1 equals 15a plus 4. We'll choose to subtract 7a from both sides so that our coefficient of a is positive. Again, not a big deal if you subtracted 15a from both sides. Just be careful with the negative coefficient when you divide through. That gives us -1 equals 8a. 15a minus 7a gives me 8a plus 4. I have now got my variable terms together. In this -1 equals 8a plus 4 equation, I only see the variable coming up one time. I only see the a in the term 8a, nowhere else. Now I can isolate the variable term. Nothing left to simplify. I can isolate the variable term by subtracting 4 from both sides. 8a plus 4 minus 4 just gives me 8a. And -1 minus 4 is -5. And I've now fully isolated the variable term. I get 8a equals -5. The 8a term is by itself. And the last thing I need to do before, in order to isolate the variable itself, is to multiply by the multiplicative inverse of the coefficient. Multiply by 1/8. 8 times 1/8 is 1, or 1a is just a. And on the left, I have -5/8. So my answer is a equals -5/8. And then I plug back in, I check, and I see that this answer is indeed correct. So I found the one and only answer to this problem. Any questions on that one? Okay. So checking is a little bit tedious, but it's not too bad, especially because the fractions on both sides like all have the same denominator of 8, or they're integers, so that makes it a bit easier to work with those fractions. And then our second problem, solve 5x plus 7 equals 16x minus 9. Again, I see I have variables and constants on both sides. So I'll start by getting my variables together, getting my variable terms together. And I'll choose to subtract 5x from both sides, again, because that gives me the positive coefficient. If you did it the other way, not a big deal. So 5x minus 5x is 0, plus 7 just gives me 7 on the left side. And on the right side, 16x minus 5x is 11x minus 9. The minus 9 just comes down. And at this point, I have my variable terms together. I only see my variable occurring once in the equation, in the 11x term. Now I isolate my variable term. I have 11x minus 9. So I add 9 to both sides. Minus 9 plus 9 gives me 0. My right side is just 11x. And my left side, 7 plus 9 is 16. I've now fully isolated my variable term. The 11x is by itself, and everything else is on the other side. And now I have the 11 multiplied onto the x. I undo that by multiplying by the multiplicative inverse, 1/11. 11 times 1/11 gives me 1, or 1x is just x on the right side. And 16 times 1/11 is just 16/11 on the left. And again, I can plug back in and verify that this is the one and only solution. Any questions on any of this? All right. I don't want to start into solving equations with fraction or decimal coefficients. We're going to leave that for next time. So next time, what we'll plan to do is take a look at solving equations with variables and constants on both sides. Maybe some slightly more challenging problems. Maybe we have to do a little bit of simplification first. We'll continue on with this format now that we're moving into material that it's not really our first introduction to this material. We're kind of, refining our abilities at this point. So we'll continue on with this format where, I'll do an example or two and then give you an exercise or two to work on your own. And we'll keep going like this through the rest of section 8.3 and 8.4. And then depending on how much time we have, we'll do a little bit of chapter 8 review at the end of class next time. And again, that takes us to Thanksgiving break. But plan ahead, even this week, it's probably a good idea to write out a plan for what are you going to accomplish this week over break, the week we come back, and then we're already into finals week. So we're getting on that home stretch. So make sure that you have kind of a good plan set up for the next 3 weeks or so. It's gonna, final exam week is gonna be here before you know it. So any questions on anything that we did today? Let me stop the recording. Any